Okay, I think we'll get started. Good morning, everyone. Happy Friday. Thank you for being here, and thank you for having me here. It's probably been a long week for everyone. I'd imagine you've learned a lot in this week. And you'll have to excuse me if you can't see me when I step in front of the screen. I fell asleep on the beach my first day here because my hotel wasn't ready, and I'm about darker red than my shirt right now. So I'm still working through that. My name's Dan Rosanova. I'm a program manager in the Azure core team. I'm responsible for all the messaging services in Azure, so Event Hubs, Service Bus, and Relay that we're going to talk about today. And let's quick poll, I guess. Who's using any of the Service Bus or Relay or Event Hub services today? A couple of people? Good. I'm actually kind of more glad for the people who aren't, so I want you to learn some about them. Messaging. Messaging is an interesting topic. I've worked in it for most of my career. If your view of messaging when you saw this session was this, I'm sorry to disappoint you. This is not what we're talking about. I will not hold it against you if you get up and walk out right now. So there's not going to be any Skype or Exchange or anything here. But in reality, messaging isn't really that different, what I'm talking about today. It's instead of person-to-person messaging, it's machine-to-machine messaging. So we have 3 services in Azure that support this type of work. The first is Service Bus. Service Bus is a name we've used for almost a decade to describe messaging in Azure and at Microsoft. It's just one piece, though. So it's really reliable, asynchronous message delivery. If you think about something like MSMQ or MQ Series or TIBCO, this is going to be something like that. The next is Event Hubs, which is a slightly newer service. It's really a distributed data streaming platform, so kind of like a distributed log as a service. Then the last one is Relay. And we'll end with Relay today. Relay is pretty interesting because there's really nothing quite like it. Whereas Service Bus has things like TIBCO, and Event Hubs things like Kinesis from Amazon, or even Kafka as similar services or similar products. Relay is really unique. It's a live bidirectional socket connection that goes through the cloud to get through all sorts of network trouble. It's a fun service. We'll end with that. That's the one that always creeps out the security people when I bring it up. So let's start by talking about where you can use messaging and where messaging is commonly used. The first of these 6 major industries that I've seen messaging used very heavily in is financial services. This would be for things like interbank transfers. This is actually a really good analogy because you have 2 banks that are separate and they're trying to transfer something to each other, which is really just digital information, since all money is kind of fake now and it's just bits anyway. But it's something you want to have be reliable, be non-reputable, and be something that kind of supports our entire global economy. Order fulfillment and trading, this is a really big part for messaging. So when you actually make stock trades or commodities trades, actually filling those trades, that's another example, a classical example of how messaging is used. Settlement, which is kind of filling those orders at the end of the day, and reconciliation. Does anyone work in financial services here or have in the past? Yeah. Did you ever see messaging stuff while you were there? Probably. You know what, actually, I wanted to remind everyone, because I'm from Chicago originally, so I'm used to bribing people. I've got prizes for people, and so I've got pens, and you're going to get a pen. Just throw it, okay. No, I'm not going to throw that. I haven't had a full night's sleep in 4 days, so that's going to be a liability. I suppose we're not in the States. It's not as bad. Go to jail for that. Okay, so let's see. What else? Pricing and quote updates. So this kind of stuff is big enough in financial services that this is really kind of how stock exchanges work and stuff like that. Utilities and telecommunications are actually another big user of messaging. Utilities are a funny story because if you haven't worked in that industry, you might look at them from the outside and think they're very antiquated and very out of date. They were actually some of the companies first forced to use technology for things like billing. So they got a lot of legacy around, and they've got a lot of new stuff. Some of that legacy might be their customer information systems, which even today still tend to be mainframes in a lot of utilities. Their billing systems tend to be separate. They have all these separate systems and need to integrate them together. They use messaging to do that. And then on the newer side, they have things like smart grid and smart meter. I worked in this industry for a few years before coming to Microsoft. It's very interesting. It's really cutting edge. and it involves a lot of messaging. So if you think about a smart meter pinging out your electric usage every 15 minutes, or letting you turn on and off appliances remotely, that's all messaging right there. And then the last piece is that a lot of utilities actually use sort of private messaging networks to do command and control of their utility network, whether it's a power grid or a water grid or whatever. Logistics and transportation is another really big user of messaging. This makes sense as you look at it. Something like processing an order. So if you're purchasing something and how that gets fulfilled. E-commerce is a really big user of messaging. Almost every time you see a shopping cart somewhere, that's really a messaging system on the back end or a messaging workflow. Delivery notifications. Almost every company that delivers stuff lets you sign up for notifications about when it's coming to your house or your business or whatever. Inventory management. This actually goes back a long way. Things like barcodes. Like a barcode is all about inventory management. And in the past, that might have been within a store, but today that's across stores with things like RFID or QR codes. And routing, so typical kind of traveling salesperson type stuff, how you route stuff around. Insurance is actually a really heavy user of messaging. Anyone work in insurance here? Cool. You can have a sticker. Sorry, I'm not gonna. I'll give toys away at the end. You're too far away. Insurance is a heavy user. When you look at an insurance company, they tend to have their systems set up in sort of a pyramid, where you have the crown jewels at the top of the pyramid. That's really things like enrollment or claims processing systems or policy systems. Then you have supporting systems below them, which are a little bit less critical, but important nonetheless. And messaging is used to get between those. An insurance company is an interesting thing to look at, even more interesting maybe than financial services, because at the end of the day, it's really just an information company. That's what insurance companies are. They don't sell widgets. They don't make stuff. They really just handle information. So they're big on messaging, and they're usually very heavily regulated. So a lot of the regulatory filing is through messaging. Healthcare is another big one. In the U.S., we were kind of behind on medical records, but we're catching up. Quality care metrics, that was actually introduced by the Affordable Care Act recently, a couple years ago, so it's something that's growing. And then again, kind of like with smart grid and smart meter, patient monitoring and diagnostics sort of gets you to this almost IoT type world where you're doing something beyond what we've done in the past. It's all, again, messaging. And then lastly, the biggest purchaser of messaging in the United States is government. And you probably don't really want to know what they're doing with it. The Department of Homeland Security is the #1 purchaser of messaging products in the world. And before Edward Snowden leaked what they were doing with it, they had to collect that data, right, to have it. So they do it through messaging platforms. Or if you come to the States and use the kiosks to get into the country, that also goes through a messaging product. It's not a Microsoft one, but it's a queuing product from a large company that has 3 letters in its name. This is a list I took about a month ago from our own CRM system at Microsoft, listing the current customers of those 3 messaging services. And an important thing to keep in mind here is that all 3 of these products are PaaS. We don't have non-PaaS offerings. Like, this is all platform as a service in the cloud, messaging built for your industries. Does anyone work in an industry that's not listed on here? I'd expect no hands to go up here. This is pretty much everything. I guess there could be 1 or 2. We'll start today with Service Bus, which when I say now, I really mean queues and topics. In the past, we put all this fun stuff into one thing and called it Service Bus, and some of them had nothing to do with each other than the fact that they're kind of messaging. But if you think about anything in the cloud, it's all going over TCP/IP. It's all messaging, right? But that's kind of a bad analogy. So Service Bus is really enterprise messaging as a service. It's just queues and topics. That's what the focus is here. And it's reliable, asynchronous communication. It's going to give you features like rich temporal control, so you can control how messages are flowing in time and when they're effective, and give you things like routing and filtering. Not sure which one that was. And then ways to relate messages and state together so that you can have a lot of messages make up a convoy or a session or something like that. Where does Service Bus fit into your applications or your enterprise or your business? These sort of shapes would look fairly familiar. You're getting stuff in the cloud or on-prem, doesn't matter. You have stuff you're trying to tie together. A good example would be some sort of front-end UX, and then you have some sort of back-end processing, usually involving state, because state is what's interesting. Who uses architecture kind of like this, front-end, back-end? Anyone ever? No one? Wow. Client-server never made it here? Okay, a couple of people, good. How you really tie this together, especially as you get to really distributed systems like the cloud, is through queuing, is through some sort of queuing. And that's where Service Bus fits in. At all those industries from before, these are the types of messaging patterns people use to really support their workloads. Because at first, messaging is really deceptive because it sounds so simple, and you almost wonder, why do I need it? I'll just send a message. I'll just send an HTTP post with the data I want somewhere and figure it out. But these are what you're trying to solve with messaging. And we give you features and tools we'll get to in a minute for how you do that. But a simple one is load leveling. Load leveling sounds simple, and it is, but it's deceptively simple. It's extremely powerful. If you take something like an ERP system, ERPs usually, even still today, all of them tend to be monolithic applications. They're running on a finite set of hardware. There's not a whole lot of cloud ERP yet, unless it's sort of IaaS-based. And what that means is that you have a finite pool of resources that you can use for your ERP. So you wouldn't necessarily want to expose that to, like, the web or something. You don't want people to hit your ERP in an uncontrolled way, because they could really hurt it. Load leveling is just putting a queue in front of it, and then the messages go into the queue. The website talks to the queue. The ERP can pull the messages out at a speed that it wants. So if you have sort of spiky, bursty traffic, you can keep a constant flow into your downstream systems. So it's a very powerful feature, actually. Load balancing is similar to that, but the intent is what makes it different. You're still putting a queue in front of something, maybe still an ERP system, but now it's something that has maybe multiple back-end servers that can serve the requests. So they all pull from the same queue, and you're actually balancing the load across all the servers. So the intent is different, but the tool used to solve them both is the same. A lot of other things on here, like scheduled delivery, workflow, dead lettering, correlation, and expiration. These are all things that people do with messaging. A really good example for expiration, back to the trading industry, and a lot of these actually come from the trading industry, would be that you have a trade, like a market order, and you want to buy stock in Microsoft at some price that's good till the end of the day. That's in like the US markets, that's sort of the default for a market order, is good until end of the day. You could also do something like good till canceled, but that way expiration gives you a feature in the messaging platform to say, if this message is not read or fulfilled in this time, just make it go away. So we give you a lot of features in Service Bus to do this. Service Bus is actually the most sophisticated messaging platform in the cloud right now. It has been for a long time. One of our competitors across the lake in Seattle is trying to catch up, but they're still really far behind. Some of these are simple things like scheduled delivery. I might have a message I want to send now, but I don't want anyone to act on it until later. So you can actually schedule a future time that the message will become visible. Again, it's a deceptively simple thing, because at first you think, well, I'll just write some process that stores it in a database on my side and sends it later. But you're actually adding debt to your side of your application. This is really useful for things like closing books at the end of the day. You can send a command in the morning that says, run this at the end of the day to close everything out. Poison message handling, it's something we have by default. Pretty much every messaging system that's not extremely naive has this. It's how a poison message is what you call it when it's something you can't read or process. So it'll be stuck in the queue. And if you have too many of them in the queue, over time you'll end up jamming the front end of the queue with messages you can't read, and all your traffic will stop. So over the 3 decades of painful messaging that people have gone through, they've figured out ways to solve this. For us, it's that if you read a message from a queue 10 times and you can't complete the message, we'll just dead letter it. Forwarding, defer. Defer is a feature I like to use in my private life, which is I'm not ready for something, just make it go away. So we give you that. And then sessions, I won't really talk about them too much today, but if you don't know much about messaging yet, look at these things and really look at sessions, because it's something that really sets Service Bus apart from its competition. It's a way to have in a queue, which is a competing consumer construct, like a table in a database, it's a way to have a set of messages related in strict order with state, so that you can do things like workflow. And then there are some other simple ones. I could do a whole hour talk on sessions. We will not do that. There are other simple things like duplicate detection. These are powerful, simple things that are easier to put in the middleware in the messaging than to write on your own. Basics of a queue. Queue looks like this. You got a sender, you got a receiver. The whole idea is you're trying to decouple those two from each other. You don't want them to know about each other. So your sender is sending a message to the queue. The queue is replicating it, storing it, and acknowledging back the receipt of the message. So now it's safe, it's in the cloud. We'd really have to lose a whole region to lose the message. Now a receiver at some other time, then or in the future, connects to that queue and retrieves the message. They take a lease on the message saying, I'm working on this now, so the message still exists inside of Service Bus, but it's not visible to anyone else. And then the receiver can acknowledge back and complete the message, or abandon the message, or defer the message, or whatever they want. And then the message goes away if they've completed it. Again, deceptively powerful stuff. The idea here is that you are decoupling sender and receiver. You can even do things like have senders have credentials that are only good for send, and receivers have credentials that are only good for receive. So that you're getting a lot of power out of this. Topics and subscriptions are something a little bit more advanced. It's kind of like a queue plus plus. The idea here is that you have a topic. The topic looks to the sender just like a queue. You just send to the topic. And you have subscriptions hanging underneath that topic. And they look to the receiver just like a queue. Receivers just read from that subscription. But the subscriptions themselves have filters on them, so you can route messages between all of the subscriptions. Like a simple example is you can do content-based routing on headers in the message to flow different messages to different parts of your topology. And this is useful for some things, like not having to build what we would call a universal dispatcher, so something that reads from a queue and has to figure out what to do with every message. That's really good at first. It's very easy for the first few things you have to do, but as you have to add more and more things to it, you make this big, giant pump that is complex and breaks easily. But this is actually even more useful than you might realize at first. When you look at cloud systems, or any distributed system, you're usually using a lot of pieces. And they're not going to all deploy at the same time. And if you have long-running processes, you can't really just turn them off and kill everything and start over again. I mean, you might be able to, but that's not realistic for a lot of workloads anymore. People don't really like having the downtime. A simple way to use topics to solve that is instead of routing on type, you could route on type and version of the type of message. So you have order v1, type equals order and version equals 1. And when you roll out a v2 of your system, you can keep the old stuff there, including the old executables, and deploy new subscriptions with order v2. And now you can run both side by side for as long as you need to transition or drain out the old data. So if you have like long-running day or week-long running processes, this is a way to do that without breaking stuff. So it's pretty powerful. But the enterprise messaging space is nothing new. I've talked about 3 decades of legacy here. We have it. Most companies have some sort of messaging platform in place. Very large companies, my observation is they tend to have 3. People seem to like odd numbers greater than 1. I don't know why. And they'll look like these. So you'll see some WebSphere, you'll see some BizTalk, you'll see some Oracle or TIBCO. But what's interesting is that these are all still on-premise platforms. So you have to run these yourself. And that's actually a lot of work. Has anyone here ever been responsible for running an email server? Yeah, a couple of hands. Did an executive ever tell you how well you were doing with the email? Yeah, no, yeah, exactly. The only time CEO talks to you about email is when things are not good. And this is the same way. This is messaging just of a different type. And there's not a lot of glory in running it, but there's a lot of pain when it goes wrong. So this is all starting to move to the cloud. It's really just starting now, and we're pushing it hard. We're pushing this as a vehicle, Service Bus as a vehicle, to get your messaging off your on-prem and into the cloud. How we're doing that is that we're developing the product into different tiers. In the past, we had things that were multi-tenant, that were very low cost, that were really kind of built more towards the startup type companies who might not care about latency. And what we've done last year is we introduced a premium tier that lets you have dedicated resources for your workload. It's really almost like running your own server, except you don't have to run it. So it's still managed fully. It's a real PaaS service, not some sort of like pre-configured IaaS that you have to update and patch. All the load balancing is done for you, everything like that. And all you have to do is decide which tier fits your needs. So someone like an insurance company or bank, probably wants something like premium. Someone like doing cat photos on their website, maybe just wants something like basic. And what we're doing with these is also making them a little easier to understand how they fit into your enterprise and fit into your business. Because premium isn't just about performance, it's actually about predictability. So predictability in performance, so you get the same latency all the time, which is that big set of features that I mentioned. All of those features require different resources. So which resources you're using kind of shapes how fast your workload can go. And in a shared platform, we can't control who does what with the messaging, so you might get latency. And in premium, you don't. It's always defined CPU, defined memory, defined IOPS. So your workload will always work the same way. It's also about predictable price, though. What's interesting as you get into the more enterprise space is people want to be able to predict their price a year or 2, 3 years out into the future, because they have CFOs that care about this stuff and ride them pretty hard about it. Our sort of multi-tenant standard and basic platforms, they're usage-based pricing, so it's kind of hard to predict. It depends how much work you're actually doing, whereas premium is a fixed daily price. It also allows larger messages, which is kind of more common in the enterprise environment, and higher scale, so there is a performance aspect. And then lastly, it's about giving us the space we need to do more innovation so that we can add more features, and if they take CPU or resources, it's just your resources, so you're making an explicit decision to use your resources for something that you actually want. But it does also mean performance. So there is a performance aspect that's pretty big with premium. This is probably a little hard to read, not too hard. And what you can see here is send and receive performance for premium messaging, which we sell in messaging units. The green bars on the left are a single queue. So a single queue doing messages per second, and you can see it scales really very linearly as you buy 1, 2, and 4 message units. So you're going 4,400, 9,000, almost 17,000 per second, which is pretty fast by enterprise messaging standards for durable messaging. The other colors are different workloads, so you're using and adding different features, but you can see that even the same features, they scale linearly because you're actually getting your own resources. Now I'll talk a little bit about Event Hubs. Event Hubs is distributed data streaming. So this one, a queue kind of makes sense. Did the queue thing make sense for everyone? That's kind of a new way I explain this, yes? No? Maybe? Okay, a queue is pretty simple. A queue is a server-side cursor. So like you're connecting to a queue and saying, give me the next message. And the queue knows what the next message is and gives it to you. Data streams are a little bit different. Event Hubs is a little bit different. It's a streaming service that's designed to do low latency. It's designed to be high scale. It's a partitioned consumer model. So instead of a queue, which is a competing consumer, like a database, like a table in a database, everyone's fighting for the lock on the table. So eventually you hit a speed limit in how fast a table can go, whether that's a latch in SQL or the other mechanism that Oracle uses. And it's a time retention buffer. So unlike a queue where the data goes away when you read it, in an Event Hub, the data stays there. It's a stream, the data stays there. You can read it over and over again. And importantly, it's an elastic component made to hold your sort of telemetry pipeline together without breaking. Here's sort of where Event Hubs fits in to your enterprise. You can see that this is a chain. It moves in one direction, left to right. It's a pipeline, really. You have things producing data, applications. They could be devices, whatever. Some of them will talk directly to the cloud. Some of them talk through APIs or through gateways. And your data comes in for ingress into Azure. So that component is the elastic piece, is the ingress. After that, you usually have 2 streams of data leading out. The first is a fast data stream. This is what we designed Event Hub for, real-time analytics on a stream of data. The other is a slow data stream. We actually commonly see people do both of these. We designed our platform to let you do both, and we've actually improved the slow data stuff. After that, you're moving on from stream processing, which might be alerts or anomaly detections or whatever, or even just storing stuff for long term, to storage and then presentation and action, giving users a way to see information and to react to it with other tools in Azure, like Power BI or Cortana or something like that. This same model works. If you take the Azure pieces out of it, the same concept works on any other cloud provider or even on-prem. In Event Hubs, the common usage pattern is really telemetry. It's logging and telemetry. So there's a lot of IoT involved, but there's really the number one thing is application logging and sort of performance logging. So application logging would be something like Log4j. You know, your code is just spitting out logs as it's going to say, I'm here, I'm doing this, whatever, here's my current state. Whereas performance telemetry is more, how fast is the application responding to requests? You know, what's the health of the application itself, sort of separate from what it's doing. They sound similar, but they're really different things. And people dashboard off this. It's the most common usage. We do get some people that do transaction processing, especially very high-scale transaction processing. Features we give you to do your telemetry and streaming stuff in Azure with Event Hubs are Archive, which I'll talk about in a second. They're proximity, meaning you want to group data together. Maybe you key them so that Dan's data is in one place and Bob's data is in another place. We do give you consistent playback and strict ordering as options. Well, the consistent playback is always there, but strict ordering is an option. And we give you tremendous scale. Event Hubs will scale up in a dedicated capacity model to 1 million events a second, no problem. So how's it different from a queue? Because this is fundamentally different. Does anyone know what this is? Okay, yeah. I know one day I'm going to ask an audience and be like, oh, it's probably going to happen in like San Francisco or something. So this is an analogy I've started using just recently to describe how Event Hubs kind of works and what's different from a queue. Is that it's a stream. It's like a tape. You're recording on a stream. The recording just moves forward. You just keep recording. You can play this tape over and over again as many times as you want. And you can fast forward and rewind to different parts of the tape and play again. And slight difference, like some tape decks, I guess, the tape loops when it's done. That's what the buffer thing is. Old data dies off and new data comes in on a daily limit that you set. Another good analogy is it's kind of like the tape deck that the tape gets played in. You can fast forward, you can play, you can record. And this analogy also works for looking at partitions. If you look at a cassette, it actually has like left and right channels. A CD does too, so does an MP3. But they're really different channels of data. So the left channel is one set of data, the right channel is another set of data. But when you press record, they record both. And this is like if you listen to music recorded before sometime in the 80s, you'll hear like drums on one track, like on the left side, and guitar on the other. But fundamentally, the data on each channel is different. It might be related, it might have some bleed over, but it's different channels, different data. And a good analogy for this on the tape deck, who had one of those ghetto blasters when they were a kid? I had one, yeah, or maybe not a kid, is that the left and right speaker each play one channel of the data playing back. In Event Hubs, those channels would be called partitions. So that's the way to think about what partitions are in Event Hub. It's like a tape, and the partitions are like the tracks on the tape. And you can add more partitions. You create one, and by default, I think you get 2 partitions. But you need a speaker to play that partition. So you can get 4 partitions. You can get a lot of partitions. And at some point, this thing's going to be hard to carry around. So it's not always more is better. It's not a case that more is always better. Here's a little bit more of a conceptual view of what an Event Hub looks like. And when you look at an Event Hub like this, here's our friend, the Event Hub. Here's its partitions. We saw those earlier. The partitions have data inside of them. So that's the data in those tracks. And the data is totally separate from the other tracks, from the other partitions. When you're sending your data in, your event producers are usually just sending generically to the Event Hub. They're not thinking about what partition it goes in. That's actually kind of an anti-pattern. So they just send the data in. They can do it over HTTP or AMQP. Data flows right in. If you just use the defaults, it's going to round robin between all the partitions. This will give you the best availability and performance. Anyone know what CAP theorem is or Brewer's theorem? There's some stuff here that's related to that. So you can choose to use partition keys to send data to specific partitions, and that can be useful, but you're making an explicit choice when you do that about availability. You're saying order or proximity is more important than availability. So you're making a trade-off. Just be aware. Kind of little gotcha. I'm reviewing an article about explaining that for our documentation right now. To read out of the Event Hub, you need receivers, like the speakers again. You need one for every channel, so one for every partition, and they're reading through a consumer group. Now you can read, unlike a tape, you can read concurrently. So you can have a second consumer group reading at its own pace. And again, remember, these are client-side cursors. So when in consumer group 2, when the first reader connects to the first partition, it says, I want to connect at position X, and then I'm going to press play from X forward. And you're just reading the stream after that. So it's subtly different than a queue, but it's a big fundamental difference when you're designing your systems. Server-side versus client-side cursor. It's really you having to do a lot of work versus us having to do a lot of work. And picking which model is better for you is something you have to spend some time thinking about. Event Hubs is sold in a similar way to Service Bus. We have a basic, standard, and now a dedicated tier for it. The first 2 are multi-tenant. The last one is really a dedicated cluster. Again, we're going to give you more features in the dedicated thing. Again, it's paid for by the day, not by the message. So it's really made for people who need very specific workloads, very specific scale. Scaling Event Hubs, this is an interesting one, especially for partition systems. Does anyone ever use like Mongo or Kafka or anything? You have to repartition stuff. That's fun, right? Yeah, that's a good time. That's a good Saturday night or Friday night right there. In Event Hubs, you scale through throughput units. It's a reserved capacity unit that you purchase by the hour. It gives you 1 megabyte or 1,000 events per second per throughput unit, and twice that amount of ingress per second, and twice that amount for egress. So you can send in 1,000 messages a second, and you can read out 2,000 messages a second. hence why my previous graphic coincidentally had 2 consumer groups, even though you can have up to 20. The idea here is that we do expect you to go fast and slow at the same time. This limit is namespace wide, which is a fully qualified domain name. You can put 1 event hub in that namespace or 10 event hubs in that namespace, and whatever throughput units you purchase are spread across all of the event hubs and the partitions in them. And when you hit that limit, you're going to be throttled. The important concept here is that partitions are separate from throughput units. So you don't have to reshard when you change your scale in event hubs. That's a key selling point that we have for event hubs. In partition systems, you usually have to reshard to go faster, which can be a pretty painful operation and often requires downtime. So quick pricing sample for event hubs. I didn't really want to talk about pricing on our other stuff, but this one's pretty good because it's compelling. Is you're buying a throughput units. You saw it on the pricing earlier. It's 3 cents an hour for standard. Gives you 1,000 messages a second. That's 72 cents for the day. These are in US dollars. You can send 86 million events throughout the day for that 72 cents. You pay for the million events. Each million is 2.8 cents. It's going to cost you $2.42 a day. And out the door, you're sending 84 gigs of data for $3.14. And it's all sub-second. And it's all triple replicated. So, I mean, it's a pretty compelling value proposition. But that's not that much. 1,000 messages a second, maybe you have a big website, maybe something else, I don't know. What if you need 1 billion messages a day? That comes out to about 12,000 messages a second if you have an even distribution. And you might have an uneven one, but we can do that too. But just if you have an even distribution, 12,000 messages a second, those 12 throughput units are going to cost you $8.64 for the day. You can send your billion just a little bit over if you're going 12,000 a second for $29.03, and it's $37.67 to send a terabyte of data that's triple replicated, that's sub-second. If you can find a cheaper, faster, more reliable messaging service in the cloud, by all means use it. I will not be offended. But the funny thing is we worked very hard to make Event Hub sub-second and really fast and all this great stuff. But we realize that the majority of customers still want to persist their data for long-term use, for batch processing, maybe just for audit purposes. So they were all reading the data and writing it to storage themselves. So we added a feature in to make this easier. It's in preview everywhere in the world right now. We're going to GA it very shortly. And it's Archive. Event Hub Archive lets you go fast and slow with your data stream, like I showed you before. The idea here is that we're automatically going to send data to a storage account of your choice. It's your storage account, not ours. This is made to really serve batch scenarios better and near real-time scenarios rather than hard real-time scenarios. Or I shouldn't say that because in the real-time world, that's craziness. But it's really an idea to minimize your overhead. So you don't have to run any compute to do this. You don't have to maintain any code to do it. You show up with a connection to your storage, and that's it. And here's how it works. Here's our old friend, the Event Hub. There's its partitions. They've got their data. And you give us a storage account of your choice, like a blob storage account. You give us a window to configure for time and size in megabytes and minutes. And when we hit that window, we're going to create blobs for each of the partitions with all the data that happened during that window. Today, we use a fixed naming convention to do this. Early next month, we are changing this. So we're giving you the ability now to name files however you want. We do still require these same pieces, the namespace, the Event Hub name. So namespace is fully qualified domain name. The Event Hub name is something you're choosing also. Partition ID, date, and time. We need these so you don't have collisions with other Event Hubs and with other partitions within your single Event Hub. There's no restriction in how you order these, but you have to have all of them present. So if you miss one, we're not going to let you configure it. And you can choose your own delimiter or have no delimiter at all between these. So here's one example, using the $ sort of macro for this, where you can get names that sort of better fit your needs. You can type in constant strings if you want to differentiate between environments, things like that. This, sometime in the first half of March, we'll turn it on globally. So this is a pretty cool thing to use. Event Hub's Archive, it's really just about making your life simple. It's something you just click to turn on. There's no code to run or compute to manage. And it'll let you use your current batch processing stuff, because as much as I hope you learned some really cool stuff here this week, but the reality is most of us live in a world where we're still doing batch processing somewhere. Like that's reality, and we're not going to change that. And this is designed to let you do that easier. Like I said, it's public everywhere in public preview, and you can try it right now in the portal. And actually, I think I might take a second and do that. What we're doing with this is just dropping one of those connections so you can do it yourself. Let's see what this looks like if my computer's still on. I never do live demos, so I'm just jinx myself by saying that. Okay, here's my computer. Okay, how easy it is to set up an Event Hub and set up Archive. This is pretty cool. Come here, hit New, go pick Internet of Things. First, you have to create a namespace. So the namespace, like I mentioned, it's a container, really, it's an FQDN. I'm going to say Dan's NS 7. Let's see. Okay, yes, that's there. I pick my account for it. I'm going to use an existing resource group or a new one. I'll do a new one. And pick a place I want to do this. And since I've never actually been here before, and I don't get to use these regions very often, I'll pick one in Australia. This will take just a small amount of time to configure. It's actually setting up a DNS for me right now. You can see it's telling me, hey, look, you've got your deployment started. I'll take one moment. If I go look at all of my resources, it actually happens faster than the portal shows you, but yep, here it is. So it's deployed. I can come in here. I don't actually have any Event Hubs yet. I just have the namespace. And now I can come in here and add Event Hubs to it. Hit plus for an Event Hub. I'm going to give it a name, whatever name I want. The defaults for partition count and message retention are okay, although I could always change those. And that's why I don't do live demos, right? Okay, I can change these things like message retention to have 1 to 7 days if I want. I can turn on Archive, and here's what I mentioned. It's this window. It's time and size. So whatever you hit first, if you've picked 1 minute and you're not sending a lot of data, it'll do the 1 minute. If you've picked 15 minutes and you're sending a ton of data, it'll do that. And now I just pick my storage container. I've got one in this subscription. I'm just going to, oh great, awesome. I thought I had one in this subscription. Either way, just click here, grab your container. It'll populate down here and hit create, and you've got your Event Hub rocking and rolling. Now, you do have to actually send some data for it to actually show up. Like, we won't start writing empty files until you send your first data, until you load the Event Hub. But when you do, you'll be able to see all of the data that you've created. That's in the same region. All the data that you created dropping into the same file. And actually what's interesting here is you can see I can actually spread stuff across different subscriptions, which is dangerous because one of these I pay for, so I'm going to have to go change that. Looking back at this picture, what we're doing is just stripping away pieces here so you have less work to do. Event Hub Archive is the easiest way to get data into Azure. You can HTTP post to Event Hubs, and the data will show up in your storage account. Right now, we're doing blob storage. We're going to light up ADLS, Azure Data Lake Storage, probably early summer, my summer, probably June, and you'll be able to play with that then. That's our moment of Zen for today. That's messaging Zen. I really believe that the most successful messaging systems are things you don't see at all. All of this stuff should work kind of like electricity or water or email. It just happens. You shouldn't need to know about it. And that's my goal, is to make it that way. The last service I want to talk about today, before we get into any questions, is about Relay and hybrid connections, which is a new flavor of Relay that we've introduced. Has anyone used Relay or hybrid connections in here? Okay, okay, good. Someone. This is actually one of the most exciting services that I get the pleasure to work with on a regular basis, because it's really about securely connecting on-premise data or data that you can't have easy access to, and about load balancing that access and protecting those internal services from just being exposed to the web so they don't get DDoSed. So you're getting a lot of stuff from Relay here. It's relayed communication. It does not require any network changes. This next 5 minutes is when I can see who's a security person, because I'll see the fear in your face. So where does Relay fit in? Relay fits in scenarios where you might have used a VPN in the past, but what you're doing is too complex of a topology to do that. So if you have some data, it's on site somewhere, and you want to access it, this model works fine. You can have some other site access that over a VPN. Another person I work with, Clemens Vasters, likes to point out, though, there is no S in VPN. So there's actually nothing about security. It's actually less secure. You're opening a whole network connection rather than a socket. The problem with VPN is as you get more and more connections across that, it's going to become harder and harder to manage. It's going to become more costly. You'll need specialized equipment to do it, and it becomes harder to manage those resources. So this is one scenario where hybrid and relay fit really well. The other scenario is when you have data sovereignty issues. And I know it's popular in the press to say this is something about the US and the European Union. That's actually a misconception. It's everywhere in the world. Even in the US, we have data sovereignty rules. A really funny one is law firms. Law firms are supposed to they're required to keep all of their documents, even digital documents, on site in the law firm. Now, every lawyer has a copy on their laptop and they're walking around with them. But the data has to be in one place where it can be subpoenaed. So this is an interesting thing where it's not just the European Union having these issues, it's everybody. And the patterns that you do with relay is that you want frictionless connectivity. That's the real value proposition here. Unlike messaging or even event hubs, which are sort of store and forward sort of things, you put something in a queue, you read it later, this is a live request response stream. So this is made for something different, and it's really made as the basis for hybrid cloud. A lot of the hybrid stuff we do at Microsoft, anything that you see that magically lets you get to stuff on-premise is using hybrid connections or relay underneath. These are the kind of features we give you with it. Traditionally, relay was all WCF-based, which is a good transport for a lot of things, but not everyone uses it, and if you're not on Windows, you can't use it at all. So we've actually added WebSockets to hybrid connections, which is pretty interesting too. And it lets you choose your messaging exchange pattern, whether that's like a one-way message like a queue, or a request-response message like a web service, or even a peer-to-peer message. And importantly, you're overlaying security on top of your existing services, so you get added security. Relay actually gives you extra security, not less. It gives you load balancing and geo-distribution of traffic, and then endpoint discovery. So you don't have to keep track of what on-site resources you want to talk to. You can just go discover in the cloud which resources are there to talk to. It's a real-time communication proxy is the idea, is the base of all of our hybrid stuff. And it's used to decouple location, security, and network. Here's a very quick picture of what sort of like client-server type stuff looks like. You have a client, you have a server. I like these ovals, they look good shapes. Today, when these things want to talk together, sane people put these behind firewalls because you don't want to not do that. Problem is, a firewall is not going to let you in. Firewall usually lets you out. Even a proxy will usually let you out, but it won't let you in. And this is where Azure comes to the rescue here. When we look at how this works with a relay or with a hybrid connection, you have your service, you have your client, all this looks the same, but what's different is that the service, when it starts up, opens an outbound connection to Azure. It says, hey, here I am. And then when the client wants to talk to that service, they also connect to Azure. So it's a fully qualified domain name in Azure with some URI behind it. And we make network magic happen. At a little bit deeper level, this is how this looks. It's really a network rendezvous. So that service starts up, it starts a control channel. That control channel stays on. It's connecting to an FQDN in our system, which is a bunch of servers, so it lands on one specific server and stays connected. In this case, that's server B. When the client comes along, they want to talk to that service. They connect to some other server, usually a different server just out of probability or statistical probability, and that might be D, server D. What we do is when that connection happens, send a command down to that command channel telling the service to open up another socket and talk to that same exact server where the client is. And after that, all we're doing is bridging the data. So both the service and the client are behind SaaS authentication so that they can't talk to the cloud unless they're authenticated. And then after that happens, this network love happens, and a write on one socket becomes a read on the other. So the very interesting thing about something like hybrid connections as opposed to relay is that since it's a web socket, we're just shuffling frames across, and you can use that from anything. So you can use RDP over that WebSocket. You can use SSH over that WebSocket. You can access a database over that WebSocket. We don't restrict what you're doing with it. Whereas with WCF, you have to make some sort of contract, like a service contract, to know what's there to do. So this is pretty powerful stuff. It's in preview globally right now. We will GA it very soon, and we definitely think the hybrid connection story is pretty powerful here. The demo that I don't have with me today, but it's a pretty cool one to show that Clemens came up with, is what's so compelling for this. The thing that was a jaw-dropping moment for me was when he showed using this relay from JavaScript in a browser. I'm not saying Node, I'm not saying some other package, just JavaScript WebSocket connecting to something on-prem and getting the data to just show up in a browser. Like that's amazing. Like that is powerful stuff. Relay is actually most popular with ISVs. Those are our biggest users of it. And speaking about users, how much messaging do people really do? This is kind of where I want to wind down here a little bit on. Is messaging is more popular than people might realize already. These are our stats for January. In the month of January, we had 19.36 trillion requests to Event Hub. So that comes out to 7.2 million a second. We had a success rate of almost 5 nines on that, which if you do the math, though, that's still kind of a scary number. And our average latency for send on that was 50 milliseconds, including the triple replication. There were 580 billion messaging operations on service bus queues and topics. There are 2.2 million topics and queues in production, and Event Hubs is shuffling through about 28 petabytes a month of data. So, I mean, this is some pretty serious stuff. In the time I've been standing here, looking as red as this background, we've had about 22 billion events go through Event Hub, or requests go through Event Hub. That's in and out. So that's some pretty serious stuff. The big thing to remember here is that all of this stuff is just tools we're giving you, right? Like, the thing that's difficult about messaging is you're going to have to do some work with it, except for archive, because that just magically happens. So we're giving you a vehicle, and you're deciding where to take it. So when you go back to work on Monday, and you're looking around at what's in your space at work and your challenges, and what things do you need to solve, you can look around and think, okay, well, these messaging tools are tools in the box to pick to solve individual pieces. Maybe you want to lift and shift something like a website talking to Oracle into the cloud. You could lift and shift the website right into app service, into a web app with hybrid connections, and leave your database on-prem. So you can go kind of tiptoe into the cloud. Maybe you want to expose some on-premise data with Relay. Maybe you want to get rid of running your own messaging server, because that's not a very useful thing. You can ask Hillary Clinton how well that works out. Too soon. So this is a vehicle for you. Go where you like with it. I'd like to take some questions now. We got some time to kill. This is Seamus, by the way. I put him in every presentation. He got a present for Valentine's Day that was a rose. So he's playing with it there. So any questions? I explained messaging perfectly. Yeah, there's no questions. All right, cool. Yes? Ooh, that's a really good question. The question is about connectors to on-premise JMS. So this is a part of the talk I didn't give that's very interesting. JMS is an interesting animal because Java Messaging Services is a protocol, is a API and not a protocol. So at a binary level, there's not compatibility there. We've actually chosen AMQP as our transport, which is a binary protocol that is a cross-platform. So for JMS itself, you'll actually need some sort of JMS AMQP bridge. There are some out there. Apache Cupid used to be one, although they killed it. So now that's gone. You have to look at something like ProtonJ. But there are ways to send from JMS to AMQP. Yeah, absolutely. We get a fair amount of that. Our original strategy was to actually package queues and topics as a JMS thing for Java. What we realized is that JMS allows a lot of things that we don't do and doesn't work with some of the features that we do. So we actually just made our own native Java libraries that sit on top of ProtonJ to work with both event hubs and with queues and topics. Great question. Anything else? Yes? Mm-hmm.
Azure Web Apps has had hybrid connections for a little while. So
Yep.
Could you talk about the relationship or differences?
That's a great question. It's about the new hybrid connections versus the old hybrid connections in Azure Web Apps. The old hybrid connections in Azure Web Apps actually used Relay underneath the hood. And Relay is WCF-based and has some limits that aren't really that good. The new hybrid connections actually replaces the old hybrid connections. So the hybrid connection manager is actually being rewritten right now. I don't know if I'm supposed to say that. And it's going to be released very soon. And it just uses hybrid connection WebSocket now, with just DNS-based rather than IP-based communication. So it'll work better with proxies. It'll work better with firewalls. Great question. Thank you.
I was also going to ask a question about the petition event hubs.
Yeah.
If you could maybe talk to a real-life example, maybe an anonymous customer that's using petitions, and it may be in a unique way or something that they're doing with it, maybe reading from some petitions but not others, or
Yeah.
a real-life example of where you've done.
Okay, a real-life example, a really good real-life example. I could do some Microsoft ones. I can do some outside customer ones. An outside customer one, there's an ad tech company that uses event hubs pretty heavily, and they actually use partition key to make, and they do a tremendous amount of scale. It's almost as high as like Xbox level scale. And they use a partition key to make sure that the user's browser sessions are all put to the same partition because they want that data local so it processes faster. That does have, as I said, some availability impacts, but in their business, having a delay or something isn't the end of the world. They're really just doing analytics. It's not like transferring money. So that is one way. The thing you're kind of dancing around that's a little scary is never try to use our explicit partitioning as your partitioning. So like some people will come up and say, well, I have 10 customers, and I'm going to make an event hub with 10 partitions, and each customer will get an event hub. That is just pain waiting to happen. Because when you get your 11th customer, you're screwed. So like don't do that sort of stuff. If you want to group your data, use a partition key. But if you can avoid it, don't use one at all because it will give you the best availability experience. So partitioning, this article that I've got to proofread right now, is partitioning is something that is so simple at first and ends up being such a deep concept that has a fundamental impact on your flow of data. And you don't want to take dependencies on our internal stuff and expose them to your external stuff. A perfect example of that is the reason why proximity of data might be really important rather than round-robining across all of it is that at a really high scale, it's very expensive to cross partitions to join the data back together. So if your data is all separate, it's just like totally separate instances of data, then never use partitioning with it. But if your data is related, you might want to use partitioning or partition key if you're at high scale because the cost of reassembling data might be very high. But when I say high scale, I'm talking about hundreds of thousands or millions a second. So if you're at thousands a second, it's probably not that expensive to reshuffle data. You can use something like Spark to do that. You can use something like Stream Analytics to do that. And those are good choices there. So I should have probably talked about Stream Analytics a little too, because those are good friends of ours, and they make working with streaming data very easy. Any other questions? One more. Is this new hybrid connection going to replace the existing BizTalk services hybrid connections? Don't you know the answer to that one already? Just trying to make me say it publicly. It will be more flexible. Yes. This is the future for that product. If you looked at BizTalk services, there were like 5 things in it, and one of them didn't belong with the others. It was like, wait, this is nothing like EDI or any of this other stuff. Why is it here? And what we're doing is we're carving it out. And what we've actually done, too, is we've lowered the price on it because we're carving it out. So you're not having to buy all 5 things. You're just buying one thing. So, yeah, that's a great question. Thank you. I hope that wasn't recorded. Just going to smile. Anything else, or am I going to give you some time back? I'll be around the rest of the day. Feel free to stop by and ask any questions. All right, thank you very much.